Okay, so that last video stopped on me, and it says, what's the probability that the chosen woman is between 68 and 70 inches tall? So if you remember our normal curves, we're talking about a bell-shaped curve, remember, and the probability under the curve is 1. The peak of the normal curve is going to be 64 in this case, and remember the standard deviation is 2.7, which we learned different things about how far a number is from the mean. So what they're asking here is, what's the probability between a height of 68 and 70 inches? So if you remember, we could say that the height y of a randomly chosen woman has a normal distribution with a mean of 64 and 2.7 for a standard deviation. We want to find the probability that y is between 68 and 70 inches. So again, our bell-shaped curve, our normal curve, would look like this. If you remember from our previous chapters, we would change these y values into z-scores. So the standardized scores for the two boundary values are z equals, remember it's x minus the mean divided by the standard deviation. So we would write this as the probability that z is between 1.48 and 2.22. And you can either use the table, or remember we can use the distribution button in our calculator to find that the probability would be 0.0562, or about 5.6%. Okay, so let's look at this example. The weights of 3-year-old females closely follow a normal distribution with a mean mu of 30.7 pounds and a standard deviation of 3.6 pounds. Randomly choose one 3-year-old female and call her weight X. What's the probability that a randomly selected 3-year-old female weighs at least 30 pounds? So what we're doing here is we're finding the probability that X is at least 30, which is greater than or equal to 30. So we know that the mean, since I covered up my stuff, I need to find my papers, sorry. We know that the mean for this information is, oh my goodness, right here, 30.7 pounds, and the standard deviation is 3.6. So the first thing I'm going to do is change to a z-score. So z is going to equal 30 minus 30.7, the mean, divided by the standard deviation, which is 3.6. So if we use our calculator, we end up with a z-score of negative 0.19. So really, we're finding the probability that z is greater than or equal to negative 0.19. So we can either use the table in the back of our book, or we can use our calculator and do normal CDF. Our lower is negative 0.19. Our upper we can put in 1,000. The mean is 0 and the standard deviation is 1. So we get 0.575. So that means the probability that a randomly selected 3-year-old female is at least 30 pounds would be about 57.5%. one of the things that I should have probably done here is draw the standard normal curve. Remember how we talked about that's one of the things I was seeing on practice problems that we weren't in the habit of doing? So what we should do is draw our standard normal curve. We have our peak and we have our mean of 30.7. We're trying to find right here at 30 this area. So we can say x equals 30, and then we have the probability that x is greater than or equal to 30. So that's something that we should do. I've also seen where they use that notation n 30.7, comma 3.6 to describe the normal distribution. Any questions on that? Write them down, bring them to class tomorrow. So that completes section 6.1b.